Hello everyone, this is Madhav Paliwal. I am currently pursuing integrated MTech in IT from IPS DVV Indore. I have met this assignment as the first internal under the guidance of Dr. Shaligram Prajapat sir. Let's move to the assignment. So basically in this assignment we have two questions, question number 1 and question number 2. So the first question is there are three basic approaches to authentication of a user. First one is a unique characteristic of the person such as voice or fingerprint. The second is an item that the person has such as machine readable badges and keys. The third one is a procedure that the person knows such a password. Now let's move to the question. Question number A. If the password is increased in length, it is more secure against the threat of an interloper attempting to discover it by brute force attack. How much time will it take to break a password in this way? So the answer is half into number of possible passwords into time to enter one password. This is the answer of this question. Let's move to the next question. The question number B is if the data entry and transmission rate is t characters per minute, the number of characters involved for entry and replying in a login attempt is L characters, the length of the password is X characters, and the number of letters and numerics from which the password is selected is N characters. Then the time to break the password will be, so the answer is 1 by 2 into N raised to the power X into L by T. Let's move to the next question, the question number C. The question number C is calculate the expected safe time if brute force attack is carried out by truly working at a keyboard with data entry rate t is equals to 120 characters per minute. The character set size n is equals to 20 characters, limited characters only. The password length is 6 character and the number of characters L in the login is 15 character. So the answer is half into 206 into 15 by 120 minutes is equals to 4 into 106 minutes is equals to 7.6 years. Let's move to the next question. The question number D is calculate the expected safe time if the exhaustive search is added by two machines in parallel for the above data in point C. Answer: if two machines are working in parallel, then twice as many passwords can be cracked in the same amount of time. Therefore, the expected time to crack the password using two machines in parallel would be half the time it would take with only one machine. So, expected time with two machines is 7.6 years as we calculated before, divided by 2 is 3.8 years. Move to the next question. Question number E. Calculate the length of a password if 26 characters are used to create a password that will have the probability of greater than 0.001 of being discovered after systematic attack of 1 month. The data entry rate is 300 characters per minute and the login entry requires 15 characters. So the answer is by using Anderson formula 26 raised to the power x is greater than equals to 4.32 into 104 into 300 into 1 whole divided by 15 into 0.001. So the equation will be 26 raised to the power x is greater than equals to 8.64 into 108. So if x is 6, then 26 raised to the power x is equals to 3.09 into 1.08. And if x is equals to 7, then 26 raised to the power x is equals to 8.03 into 109. Let's move to the next question, the question number 2. Illustrate the public key implementation of RSA algorithm, that is reverse Shamir and Edelman, with p is equals to 7 and q is equals to 11. So the answer is step number 1. The two prime numbers p and q are selected as p is equals to 7 and q is equals to 11. In the next step, the two numbers n and r are calculated as n is equals to multiplication of p and q, that is 7 into 11, which is 77. Now calculate r. R is calculated by p minus 1 into q minus 1 as 6 into 10 is equals to 60. Now in the next step, 73, select an integer e, where e is less than r and e has no common factors with r. Now we have to assume the value of e. Let's take e is equals to 37. In step number 4, calculate the integer d, where e into d is equals to 1. Mod r is equals to 1 mod p minus 1 into q minus 1. This is the equation. So our equation, our next step will be 31 into d is equals to 1 mod 60. So the value of d will be 13. In step number 5, the decryption key, the secret key is 13 and 77, and the encryption key and public key is 37 and 77 respectively. Thank you for watching.